What's up? I'm Vin, and today I want to go through the January 2020 Geometry Regents. So let's jump into this. So first up here, we have this diagram here with parallel lines, and these are the lines that are actually parallel. And what we have is a few more lines drawn in, and we're told the measure of angle FAB is 48 degrees. So we could go ahead and label this angle here, and we have the measure of angle ECB is 18 degrees, which is over here. And what we want to find is, we want to find the measure of angle ABC, which I'll just put an X here. We want this angle. Well, because these two lines here are parallel, the alternate interior angles formed are congruent. So what that tells us is that angle BHC is also 48 degrees. And the way I recognize alternate interior angles is I look for this Z shape here. And when we draw in this Z shape here, two of the lines involved are parallel, and this third line is the transversal. So we have this angle here is also 48 degrees. So if I want to find the measure of angle ABC, notice this is an exterior angle, and the exterior angle formed is equal to the sum of the two remote interior angles. So I could say X is equal to, and we'll write it over here, 48 plus 18. This works out to, we just have 16, carry the 1. So this is going to work out to 66. So X is going to be 66 degrees. So this is going to be choice 3. For question 2, we have a cone with the volume of 108 pi and a base diameter of 12, and we want to know the height of the cone. Well, just know the volume of a cone is 1/3, and then we have pi r squared times the height. And if the diameter is 12, that means the radius is half of that, so the radius is 6. So now we just plug into this formula here. We have the volume is 108 pi, and this is equal to 1/3 times pi times the radius squared, so we're going to have 6 squared times the height. Now right away I could see pi over pi is going to cancel, and if I want to get h by itself, what I'm just doing in my head here is I have 6 times 6 is 36, and if we do 36 times 1/3, that's the same thing as 36 divided by 3 is 12. So we could just divide both sides by 12 like this. So now all the constants are going to cancel out on this right side. So the 36 times 1/3 is equal to 12. So the 12 over 12 left here is going to cancel out, telling us h is equal to 108 divided by 12 is equal to 9. So this is going to be choice 2. So next up we have a similar triangles question here. And the trick to these questions is that when you draw the triangles out, that you want to write the letters in corresponding order. So let's say I write JGR. Then when I draw out triangle MST, so here comes triangle MST, notice J was in the top position, so M, the first letter, is also going to be in the top position. And then here we're going counterclockwise, so then S would go here and T would go over here. So now these two triangles are similar and the letters are in corresponding order, so it's easier to identify. So now we go through these one at a time. Which statement is not always true? Well, J is congruent to M. This would always be true because these two angles are in corresponding location. So this one is out because it is always true. Angle G is congruent to angle T. This right away is looking like our answer because notice G is in this bottom left location and T is in the bottom right location. So they don't have to be equal. So that's not always true. Now, angle R is congruent to angle T. That always has to be true because R is in the bottom right location as well as angle T in the second triangle. So that's why this one's no good. And then last here, angle G in the bottom left always has to be congruent to the measure of angle S, or angle S and angle G have to be congruent. So definitely not 4. Choice 2 is our answer. Question 4, we have parallelogram ABCD, and we're drawing in the diagonals, and we want to know which statement would prove that ABCD is a rectangle. So if we draw out a rectangle here, and we try to draw it as accurate as we can, we have ABCD. So this is just a random rectangle. One defining property of a rectangle, aside from it being a parallelogram, is that when you draw in the diagonals of a rectangle, the diagonals are congruent. So when we look at these answer choices here, the one that establishes that the diagonals are congruent is choice 1. AC is congruent to BD. Okay, so this is an essential and defining feature of a rectangle, is that the diagonals are congruent. So definitely choice 1 here. Take a second to read through question 5. Now, the concept that you need for question 5 is that if we have segment PQ The idea is that point A, and we'll color code this, we'll put this in red. Point A is placed in such a way that it breaks this segment into a ratio of 1 to 3. So what that means is that you see how point A is here, there's one part right before A, and then there are 3 parts right after A that are all equal in measure. Okay, so this is what I visualize when I think of point A being placed on this segment. So what you have to think about here is that point A is 1/4 of the way from P to Q. Okay, so now what we have to do is we have to analyze the X values and the Y values, but the concept is, once again, is that A is placed at the 1/4 mark of segment PQ. So now we're going to target the X values. So -7 is our starting X value, and our ending X value is +5. So we have to think which value of X from -7 to +5 is 1/4 of the way from -7 to 5. Well, the idea is that we're starting at -7, but then we're going forward 1/4 the distance from -7 to 5, which we could say is 5 minus -7. And if we work this out, this is equal to -7 plus 1/4 of 12 is 3. So the X coordinate of our answer is going to be -4. Now right away, choice 4 is jumping out at me. But just to be safe, what we could do is we could repeat this process, but now we're going to repeat it for the Y values. So the Y value of our solution is going to be 1/4 of the way from point P to point Q. Now, if we work this out, we're starting at -5. So now we're going from -5 up to +3. And we want to know what value is 1/4 of the way from -5 to +3. And to work this out, we have -5 plus 1/4. The distance from -5 to 3 is 8. And if we work this out, -5 plus 2 is equal to -3. And you see there's our matching Y value. So -4, -3 is definitely our solution. Question 6, we've got a trapezoid, and we're told AB is parallel to CD. And we're also given some side lengths. AE is 5.2 units long. And then AC is the whole diagonal, which is 11.7 units long. So if we subtract 11.7 minus 5.2, that's going to tell us the length of CE. So when we subtract here, we get 6.5. So that's the length of CE. And now what we're also told is the length of CD is 10.5 units long. And the goal is to find the length of AB. So what jumps out at me right away is similar triangles, that we have to set up a proportion. And how I know similar triangles is what we need here is that we have parallel lines cut by 2 transversals. And the idea we want to use is alternate interior angles. So I look for that Z shape, and let's say I look at this angle here is congruent to this angle, and then this angle over here is congruent to this angle if we look for that Z shape. So I could say here that triangle AEB is similar to triangle, and I'm just going to make sure the letter arrangements are correct. A has a double notch, and then in this triangle C has a double notch. E doesn't have a label, and this E also doesn't have a label. And then it ends at B, which has a single notch, and D has the single notch here. So that's the letter arrangement that we want. So now when we set up a proportion here, let's say I set up X over 5.2 in the first triangle. How do I know what the corresponding side is in the next one? Well, X connects the side with the single and the double notch. So the single and double notch corresponds to 10.5 divided by the side 6.5 here is the other one that we're looking at, because 6.5 goes from the double notch to this central angle over here, which corresponds to the 5.2. So now all we have to do is solve for X, and we could cross multiply, or we could just multiply both sides by 5.2. So now let's just type this in. We've got alpha y equals, enter to type fractions. We've got 10.5 divided by 6.5, and we're multiplying all of this by 5.2. So times 5.2, and this is going to work out to 8.4. So question 6, we're going with choice 3. So question 7, we have these 2 right triangles here, and we're told that these 2 triangles are similar. So what we have is we have the right angles are at B and E, and we're told BC is 15 centimeters and AC is 17 centimeters. But what we want to find is the measure of angle F to the nearest degree. So the idea is because these two triangles are similar, this tells us, and we'll draw this over here, that angle C is congruent to angle F. And that's because they're in corresponding locations. And the corresponding angles of similar triangles are congruent. So when we're looking for the measure of angle F, what we could find here is the measure of angle C, since those two are equal. So what do we know here? We should know Sohcahtoa. This is a helpful mnemonic to know the trig functions and their ratios. So when I look at angle C, I see that this side is adjacent. This side that's not labeled is the opposite side. And this is the hypotenuse. Now, if we had to find the missing side of the triangle, we could, but we don't actually need that. You just have to think which trig ratio uses the adjacent and hypotenuse, and that's cosine. So I could say that cosine of angle C is equal to the ratio of the side adjacent over the hypotenuse. So if I want to solve for the measure of angle C, which is going to be equal to the measure of angle F, so the measure of angle C is equal to the measure of angle F, this is going to be equal to the opposite of cosine is cosine inverse of 15 over 7, and now the rest is all calculator work. So we just punch this in, cosine inverse of 15 over 17. And this is going to work out to 28 degrees. So question 7, we're going with choice 1. So question 8, we have a line and it's dilated by a scale factor of k centered at the origin. And we're told the image of the line is this line here. So what is the scale factor? So for questions like this, what I like to do is I focus in on the y-intercept. So if we were to solve this equation for y, I would have 2y, and I divide everything by 2 to get y by itself. So I'm going to divide that whole equation by 2, and that tells us y equals 1/2 x plus 4. And just know when you do a scale factor of k centered at the origin, the slope of the line is not going to change, but the y-intercept is the easiest point to target. So I think about this original line here, and the y-intercept is at y equals 4. So this is the thing to pay attention to. So I think of this point here as the point 0, 4. So what I think about is that 0, 4 is mapping to the point k times 0, comma, k times 4, and this is going to be equal to whatever the y-intercept is of this new line. So if we solve this equation for y, that would be y equals 1/2 x plus 2, just by adding 1/2 x to both sides. And the y-intercept of that new line is going to be the point 0, 2, because see how we're in the form y equals mx plus b, so our y-intercept becomes the point 0, 2. So now we think about, we have to solve this equation for k. Well, k is not going to be obvious from the first point because the 0 and the x, it doesn't matter what k is, any number times 0 is 0. But if I have this, 4 times k is equal to 2, 4 times k equals 2, tells us that k is equal to 1/2. So k equals 1/2 corresponds to choice 1. So for question 9 here, we have AB is parallel to CD. So these two sides are parallel. And then we have EH and F are midpoints of AD, and I'll label it like this. H is the midpoint of AC, and then we have point F is the midpoint of BC. So I'm just throwing in these tick marks here to show which sides are the same measure. And then we have AB is 24 units long, CD is 18 units long, and then AH is 10 units long. So we want to find the length of segment FH. So I'm just going to put an X here. Now, because these were all midpoints, we could also make the statement here that CH is also 10 units long. And what we also have is that because these were all midpoints, this third line that we construct is going to be parallel to the other two lines. So that tells us we could use this idea that corresponding angles formed by parallel lines cut by a transversal are congruent. So that means that this angle here that I'm marking is going to be congruent to this angle down here. And because these two angles are corresponding, see these two lines are parallel cut by transversal CB, these angles over here are going to be the same. So what that tells us is that triangle ABC is similar to triangle HFC. Notice they share a common vertex up here. So with that, what we could do is we could separate those triangles So I'm going to draw them separately. We have CHF, and this is 10, and this is X. And that's the thing we're trying to find. And then we have the big triangle is ABC. So we have ABC. And in this triangle, we know this side is 24. And we know AC is 10 plus 10. So this is 20 units long. So now we're just going to set up a proportion. So we have 10 over X. So the left side to the bottom side is equal to 20 over 24. Now, there's a few ways we could go forward with this, but we'll just cross multiply. 10 times 24 is 240, and that equals 20x. So now we just divide by 20, and these will cancel, and x equals, the zeros go, and then 24 divided by 2 is 12. So x equals 12, our answer is going to be choice 3. So Jaden is comparing two cones. The radius of cone A, and we'll draw that over here, cone A is twice as large as the radius of cone B. So what we have here is a situation like this. So here's cone A, and then cone B is a taller cone with a slimmer radius. And once again, yeah, the height of cone B is twice the height of cone A. So the volume of cone A is, well, what you have to know is that the volume of a cone is 1/3 pi r squared times h. So what I would do here is just pick out random numbers that fit the context of the question. The radius of cone A is twice as large as the radius of cone B. So we can say here, let's say the radius is equal to 4, and in cone B, the radius is equal to 2. So 4 is twice as much as 2. But then what we have is the height. The height of cone B is twice the height of cone A. So here, let's say h equals 2, and then h equals 4 in this one. Now, one little thing I could do 2 and 4, but maybe I'll choose 3 and 6. The reason is this formula has a 1/3, so it's probably better for us to pick a number that's divisible by 3 so that we could get rid of the fraction. But once again, this should work for any numbers that you find. So the volume of cone A is equal to 1/3 pi, the radius is 4, and that's being squared, times the height is equal to 3. And notice 3 times a third cancels. So this is going to be 16 pi. And now the volume of cone B, we're going to use these numbers, is equal to 1/3 pi, the radius is 2, and that's being squared, times the height is equal to 6. And notice 6 times a third is equal to 2. So now we have 2 times 2 times 2 is 8, so this is 8 pi. So now I think it's pretty obvious what the relationship is. The volume of cone A is twice the volume of cone B. Okay, so twice the volume of cone B corresponds to choice 1. So 10 is going to be choice 1. Question 11, we have a regular hexagon. It's being rotated about its center, and we want to know which degree measure will carry the regular hexagon onto itself. So let's draw out a regular hexagon, which is a hexagon where all the sides and angles are the same. So this is not necessarily drawn to scale, but this is my best attempt at a regular hexagon. So once again, all 6 sides of this thing are the same, and all of these angles are the same as well. But we're spinning this thing about its center. So what I like to visualize for these questions is I visualize these lines that I'm drawing from the center to all the points of the regular polygon. In this case, we have a hexagon. So if I want to find the measure of all of these angles, a full spin would be 360 degrees if we spun full circle. But because a hexagon has 6 sides and 6 points, we divide this by 6, and that tells us 60 degrees, that's the measure of each of those central angles. So this would be 60 degrees, and all these other central angles here are 60 degrees. So we would be able to spin this thing at any multiple of 60 degrees, and it would carry it onto itself. So we could spin 60, we could spin 120, we could go 180 degrees, 240 degrees, 300, 360 degrees, and I could just keep counting by 60s, but I think we get the idea. So 45 is out because 45 is not a multiple of 60. 90 is out. 120 is the answer, but you could see 135 doesn't work because that's not a multiple of 60 degrees. So definitely choice 3. Question 12, we have triangle MAH, and MT is a perpendicular bisector of AH, which means if we draw this in, if MT is a perpendicular bisector, this angle is 90 degrees, and these two sides are going to be equal in measure. Now the first thing that jumps out at me is that these two triangles share the side MT, which means that these two triangles are congruent by SAS. So we could say here that triangle ATM is congruent to triangle HTM and the postulate we're using is SAS, side angle side. So now that we know these two triangles are the same, any corresponding parts of these triangles are going to be congruent. So AM is congruent to HM, so MAH is isosceles is always true. We want the one that's not always true, so this is out. MAT is isosceles. It looks like it based on the way it's drawn, but it's not always true. I could draw a triangle that's like really flattened out like this, and what you notice is when I drop down this perpendicular bisector, you could clearly see here that these two congruent sides are not equal in measure to that altitude. So this is not necessarily true, so that's going to be our answer. But just to feel safe, we'll say why the other ones have to be true. MT bisects angle AMH. Well, because these two triangles are congruent, AMT is congruent to HMT. These two angles are the same because corresponding parts of congruent triangles are congruent. Okay, so this is definitely a bisector because those two angles have to be the same. So this is out. Angle A and angle TMH are complementary angles. Well, that has to be true because once again, angle TMH, let's say I put a theta here. This angle is equal to theta, so then this angle has to be equal to theta. And let's say I just label this as an alpha. Well then, theta plus alpha has to equal 90 because this angle is 90. So every triangle has 180 degrees of interior angle measure. So if this is 90, the sum of those two have to be 90. So that's always true. So definitely choice 2. So question 13, we have a circle and we're told that RT is a diameter. So it passes through the center. BE is a radius and chord RE is drawn. So we have the measure of angle TRE. That's this inscribed angle over here. That angle is 15 degrees. So what that tells me right away is that this angle, or this arc, I should say, is 30 degrees because just know the measure of an inscribed angle is equal to half the measure of the arc that it intercepts. And we're told that BE is 9 units long. So this is 9 units long. And we want to find the area of sector EBR. So we want to find the area of this space here. So what we have to know to find this area is we have to know the measure of this central angle. So we know what fraction of the total area to take. Well, if this angle here is 30 degrees, then this central angle is also 30 degrees because central angles are equal in measure to the measure of the arcs they intercept. But we were told that this is a diameter. So a diameter cuts the circle in half. And if you cut 360 degrees in half, you have 180. And so far, 30 is accounted for. So we could subtract 30 degrees from 180. And that tells us the missing central angle is 150 degrees. So this central angle here is 150 degrees. And now the next thing we have to know is that the area of a circle, the whole circle is pi times the radius squared. And the radius is 9. So we have pi times 9 squared, which is 81 pi. But now we just take a proportion here. The area of the sector here is, I'm just going to write equals 81 pi times the 150 degrees out of the full circle is 360 degrees. So this, the units cancel and the zeros will cancel. And this here, we could divide the top and bottom by 3. So this is going to give us 81 pi times, if we divide the top and bottom by 3, we get 5 over 12. And now all we have to do here is just reduce this. So we're just going to multiply 81 times 5 over 12 and reduce. So let's go ahead and do that. 81 times 5 over 12. And this is going to work out to 33.75. So the 33.75, just be mindful there's a pi attached. So we have 33.75 times pi. And this is going to correspond to choice 3. So question 14, we have Lou has a solid clay brick in the shape of a rectangular prism, and we're told the length, width, and height, and we're told the density here. We want to know how much the brick weighs to the nearest ounce. So for this question, we have to know that density is equal to mass over volume, and since we want to know the weight of the brick, what we're looking for here is the mass, and if we do a little bit of algebra, we cross multiply. The mass is equal to the density times the volume. So since this brick is in the form of a rectangular prism, what we have to do here is we have to use the dimensions to help us find the volume. So the length is 8 inches, the width is 3.5 inches, and the height is 2.25 inches. So what we have here is that the mass, or the weight of this brick, is equal to the density, which is 1.055 ounces per cubic inch, and we're going to multiply by the volume, but the volume of a rectangular prism is equal to the length times width times height. So now we just multiply that stuff together. We have the length times the width, and then we're multiplying by the height. Now, one thing to be mindful of here, the units here are ounces per cubic inch. So if we do ounces per cubic inch, we have inches times inches times inches is cubic inches. Notice cubic inches over cubic inches cancels, giving us just ounces at the end. So now all we have to do is use the calculator to multiply these four numbers together. So we've got 1.055 times 8 times 3.5 times 2.25. And we're going to the nearest ounce, so this is going to be 66 ounces. And that's going to correspond to choice 1. So question 15, we have this rhombus ABCD is mapped onto rhombus KLMN by a rotation about point B. And what we want to find here is the measure of angle KNM, which is over here. And what we're told is the measure of this angle CAD is 35 degrees. Now, because this rhombus was mapped onto this one by rotation, these two rhombuses are equal in measure. They're congruent, so their sides and angles are the same. Now, what we have to be mindful of here is that in a rhombus, all the sides are congruent. And what we have is that the diagonals not only bisect each other, but they are also perpendicular. So what we have here is we have 4, and let's make this a little neater. We have 4, and let's try one more time. I'll change colors even. We have 4 congruent triangles here. These 4 triangles are all congruent. So if this angle over here is 35 degrees, see it's between the single and the double notch, then this angle over here between the single and the double notch is also 35 degrees, which means between the single and double notch over here is 35 degrees, and this is 35 degrees. So what jumps out at me right away is that these small angles are 70 degrees. So I could label this angle as 70 degrees, and I could label this angle as 70 degrees. And notice A and C are the 70 degree angles, and A and C show up first and third, and then first and third here is K and M, which are also 70 degrees. So the angle we're actually looking for is K and M, and just know consecutive angles of parallelograms are supplementary. So this missing angle over here, we could just find by doing 180 degrees minus 70 degrees, and that's going to be 110 degrees. So this is going to be choice 4. So question 16, we have a lot going on here. Right triangle RST is below. Altitude SV is drawn to hypotenuse RT. So if SV is an altitude, that means these angles are 90 degrees. And since RST is a right triangle, and they are calling RT the hypotenuse, that means that opposite of the hypotenuse, this angle RST is also 90 degrees. I'll make that a little bit neater. And the goal here, once we know RV is 4.1 and we know TV is 10.2, our goal is to find the length of side ST over here. Now, there's a few ways we could go forward with this, but the best thing you could do here is you could go ahead and label the missing angles. So what I like to do is I use theta with the subscript of 1. So I have theta 1, and then I'll use over here theta with the subscript of 2, theta sub 2. And just know that theta 1 plus theta 2 plus 90 degrees equals 180 degrees. And what that tells us is that if we subtract 90 on both sides, theta 1 plus theta 2 is equal to 90 degrees. So you see how angle RST is 90, and if this piece is theta 2, then this one would have to be theta 1, because theta 1 plus theta 2 is 90. And now look at this little triangle over here. We have theta 1, 90. The missing angle has to be theta 2. So when the time comes for us to solve for x, when I set up our proportion, I'm going to know what the corresponding sides are, because I could just follow the angles. So let's say I set up x over 10.2. What I'm thinking about in my head here to help me set up the next ratio correctly to complete the proportion is to go from x to 10.2. I'm going from theta 2 to theta 1 to the 90 degree angle. So you see how that traces out x and 10.2 from theta 2 to theta 1 to the 90 degree angle. And now what I want to look for here is in the big triangle being RST, you see how RST, if I draw it out like this, the entire side down here, if I add these two, 4.1 plus 10.2 is 14.3. Here's the 90-degree angle, and then X is over here. But if we look at the entire diagram, angle T is theta 1, angle R is theta 2. So when I have to set up my next ratio, I'm going from theta 2 to theta 1 to 90. So from theta 2 to theta 1 is 14.3, and from theta 1 to 90 is X. And now I could cross multiply here, and this is going to give us X squared equals, and we have 10.2 times 14.3. Now the rest is all calculator work. I'm just going to take the square root of this and punch it in a calculator, and that'll tell us the value of X, which is going to equal the length of ST. So let's just type this in. We've got the square root of, and we had 10.2, and we're multiplying that by 14.3. And for this question, we're rounding to the nearest tenth, so this is going to be 12.1. 12.1 corresponds to choice 4. For question 17, we have two congruent pentagons, and there's a way to map this pentagon to this one by a set or sequence of rigid motions. Now, I included the screenshot over here so that if you forget the formula for rotating 90 degrees, you can see how easy it is just by turning your paper 90 degrees. So what we're looking at here is if I want to rotate this 90 degrees counterclockwise, I'm just going to rotate it this way like this. And that's going to tell us where one point maps to the other. So what I mean by that is point A, I think it's obvious here that this is at the point 2,2. So now if I rotate 90 degrees, you could see very clearly that this is mapping to the point negative 2,2. So if you forget the formula, you'll see you have to switch the X and Y, and then you have to negate the X component. Okay, and if I just try this one more time, let's say for a less obvious point, like point B, this is over 2, up 1, 2, 3, 4, 5. This is the point 2,5. You could see here that to go to point B over here, that once again, I flip the coordinates to, in this case, 5,2, but I have to negate the X. So then this becomes negative 5,2, like this. So you flip the X and Y and then put a minus in front of the X coordinate. That's how you rotate 90 degrees counterclockwise. But we could see here that if we were to rotate this, let's say I go to the point negative 2,2, and then this is going to be A prime. If I reflect this now over the x-axis, I'm going down 1, 2, and I'm going down another 2. That maps A prime to E prime, not to A double prime. So that's how I know choice 1 is out. So now I'm going to make more markings on this. We try out B. We rotate 90 degrees counterclockwise, and if we rotate 90 degrees counterclockwise, we're at the point negative 2,2. So this is A prime, and now we're going to go down 7 units. We're going down 1, 2, 3, 4, 5, 6, 7. So far this one checks out. So this is looking like a good answer choice, but what I would do is check at least one other point. So point B, we already said is going to map to negative 5,2. So that's over 1, 2, 3 more like this. So this would be the point B prime, once again at negative 5,2. And if we go down 1, 2, 3, 4, 5, 6, 7, we could see it's going to land us here. So this is looking good. Now, the reason why choice 3 is no good is if we reflect over the y-axis first. So I'm going to erase this now and talk about why choice 3 is no good. If we reflect over the y-axis, see point B is going to go over here to B prime. And now I reflect over the x-axis. You could see here this is not going to line up with this point over here. So that's how I know this one is out. And now if we reflect over the x-axis and then rotate 90 degrees counterclockwise about the origin, well, once again, you can see that this is the point negative 5,2. And now this would map to, if we rotate 90 degrees, this would map to the point negative 2, negative 5. And negative 2, negative 5 would not send B prime to B double prime. It would send it somewhere over here. So that's how I know 4 is out. Definitely choice 2. So for question 18, we want to know the area of this rhombus. And just know we could count the boxes across and up to find the diagonals. So we could go over 1, 2, 3, 4, 5, 6. So we're going across 6, and then we're going down 1, 2, 3, 4, 5, 6, 7, 8. And just know the diagonals of a rhombus are perpendicular bisectors of each other, which means this one is going to be 3 units long here and here. And this, if the whole thing is 8, is going to be 4 units long and 4 units long. And you might recognize here, these are perpendicular. So the hypotenuse of all of these right triangles are going to be 5. These are 3, 4, 5 triples. Otherwise, what you could do is use Pythagorean theorem. So the area of this rhombus is equal to, well, notice we have 4 congruent right triangles. So it's 4 times the area of one of those triangles. If I draw it off to the side here, this is a 3, 4, 5. The area of one of them is 1/2. The base is 3 times the height is 4. And if we work this out, we have half of 4 cancels to make 2. We have 4 times 3 is 12. 12 times 2 is 24. So the area of this rhombus is 24. Question 19, we want to know which figure or figures can have a triangle as a two-dimensional cross-section. So for this one here, we have to know Cavalieri's principle. And a cross-section I like to think of as a slice. So if we look at a cone here for Roman numeral 1, if we were to take a cross-section right down the middle of this thing through the diameter, here like this, we could see that this cross-section is going to be a triangle. So 1 is included in the three-dimensional figures that have a triangle as a 2D cross-section. So just imagine, once again, you take a slice right down the middle through the diameter and you're going to get a triangle. Now, the next one here, a cylinder. A cylinder is completely circular all the way throughout, from top to bottom. So this one here, we're not going to be able to find a triangle if we take a slice in any direction. The only type of shapes we're really going to be getting out of this here are, we'll have a rectangle if we go straight down the middle vertically like this. So we'd have a rectangle here. We could also have rectangles going this way, but we would have circles if we take horizontal cross sections like this. So this one's out. Now a cube, this one is probably the most abstract to see. But if we were to take a cross section of a cube, so I'm just going to draw one out here. In most cases, you're going to get a square if you take a cross section of a cube. If you take a horizontal or a vertical cross section. But if you take a diagonal cross section here, let's say that you were to chop it and you aim your slice for these 3 points here. Well, what we could see here, that even though this slice that's technically right now exiting the cube looks like a rectangle, the part that's actually inside the cube is going to form a triangle here. Okay, so a cube counts as a 3D solid that'll have a triangle as a 2D cross section. And now the last one here, a square pyramid. If I go ahead and draw a square pyramid, this one, you could just see the triangles all around this thing. But if you were to take a cross section right here, let's say on this outer part right here, you were to slice it on this diagonal, you would have a triangle. So we're going to go with choice 4, 1, 3, and 4. These solids have triangles as 2D cross sections. So for this question here, we have to know the general formula for the equation of a circle, which is x minus h squared plus we have y minus k squared is equal to r squared, where the center is hk and the radius is r. So what I do for questions like this is I like to draw them out. So what we have here is the center is at 2, -4, which is somewhere over here. So this is the center. And we have to be tangent to the line x equals -2, which is this line over here. So now, when we write the equation here, to get us started, we're going to have x minus 2 squared, because we're doing x minus h. And it's like here, like h equals 2 and k is equal to -4. So we have x minus 2 squared plus we have y minus k. But if I do y minus k, minus -4 is going to change to +4. +4 squared equals, and then this is the part we're looking for. Now, what I notice right away is that choices 3 and 4 could be eliminated. So if this is all you could do, then you have a 50-50 shot of guessing this right. But what we have here is, once again, by drawing this out, this is the center, and this is going to help us find the radius, because if our circle has to be tangent to this line, that means it's going to touch it at one location. So the center is at 2, -4. So if we look here, the line x equals -2, if I look at this point, -2, -4, that's going to help us find the radius. The radius we could just count over, goes 1, 2, 3, 4. So the radius, we could start to imagine this circle is going to look something like this. But the radius here is going to equal 4 if we count the horizontal space like this across. So since r is equal to 4, r squared is equal to 16, and this is the rest of our equation. So this is definitely choice 2. For question 21, we have to know that sine and cosine are cofunctions, which tells us here that if I have something like, let's say, sine of 70 degrees, I know that this is going to be equal to cosine of 20 degrees because 70 plus 20 is 90 degrees. So another one I could come up with here is, let's say, sine of 60. I think 60 plus blank is 90. Well, 60 plus 30 degrees is equal to 90 degrees. So that tells us sine of 60 degrees equals cosine of 30 degrees. So we're going to use that concept here, that in order for this equation to be true, 4x plus 3x plus 13 has to equal 90. And what we have here is we could subtract 13 on both sides, and we'll solve the rest over here. 4x plus 3x, this part here is going to combine to 7x. And this is going to equal, if we do 90 minus 13, that's going to be 77. And that tells us x equals 11. So now we just plug in 4 times x is going to give us 4 times 11. And there's a degrees here, a degrees unit. So the first angle is 44 degrees. And then if we use this idea that the angles are going to be complementary, that would tell us just by looking at it the other angle is 46. Otherwise, what you could do is just plug into 3x plus 13. You have 3 times 11 plus 13 degrees. And if you do 33 plus 13, that's going to make 46 degrees. So what is the measure of the smaller angle? 44 degrees. Choice 3 is our answer. For question 22, we want to know which quadrant is going to contain point R double prime, the image of point R, after a 90 degrees clockwise rotation, and then we're going to do a reflection over the x-axis. And for this question here, if we focus on point R, what I visualize is that when we rotate this 90 degrees clockwise, that's going to send us into quadrant 4, and then when we reflect over the x-axis, that's going to put us right back in quadrant 1. So if you could do that all in your head, great. Otherwise, you got to use other visual tricks. So let's say we assign this point to be the point 3, 2. So what you could do at your actual test is you could take your test paper and you could actually rotate it 90 degrees clockwise in this direction. And once again, you could see that we're in quadrant 4. And what information this gives me is that R prime, when we rotate 90 degrees clockwise, I think we could see here that we would be going to the right 2, down 3 units. So we would be at the point 2, -3. So that's what I imagine here, that I'm going over 2, down 3. And this would be R prime, once again, at the point 2, -3. So then if I go and reflect this over the x-axis, I would have to go up 3 units to get back to the x-axis, and I would have to go up 3 more units to reflect it. So this would tell us that R double prime would be at the location 2, 3. So this is if we just pick out random values here. But once again, we could definitely see our answer is going to land, or R double prime is going to land in quadrant 1. So for question 23, we want to know which ratio is equivalent to cosine of A. So we have to be able to express this ratio 3 different ways. Now, one way of seeing it, remember the ratio for cosine, if we remember Sohcahtoa, is the cosine of the angle is equal to the ratio of the side adjacent to the angle over the hypotenuse. So if we look at the actual angle A over here, adjacent to A in the big triangle would be the side AB over the hypotenuse of the big right triangle would be AC. But notice this answer doesn't show up, so then we have to look at this a different way. So now let's say we focus on angle A within this smaller right triangle, because once again, we were told that BD is an altitude. So angle A over here, in this location in this triangle, would give us the ratio AD over the hypotenuse of this small right triangle is opposite of this right angle, which in this case would be AB. But once again, our answer is not showing up. So this could be a little bit frustrating, but if you think about it carefully, over here, angle A is congruent to angle DBC. These two angles here are going to be the same. So the third way of setting up this ratio is we look at this other right triangle over here, right triangle BDC, and this angle over here, adjacent to this angle, is side BD over the hypotenuse of this right triangle is across from that right angle, which is BC. And now we just look through the answer key and see choice 2 matches that third ratio. So this question here is a similar triangles question, and we're given the value of RL, which is 2 units long, LS is 6 units long, and then we have LM is 4 units long, and then ST is X plus 2 units long, and we want to know the length of ST. But some important information we were given here is that LM is parallel to ST. So what we have here is that these two triangles, triangle RLM and triangle RST, are similar because they share angle R, and then because these two lines are parallel over here, I could say that this angle over here is congruent to this angle. So these two triangles, RLM and RST, have angle-angle similarity. So what I would do here is draw them separate. So if we look, we have RLM, and the sides that we know are 2 and 4. And once again, this angle over here is going to be congruent in a moment to the big triangle. So if we draw the big triangle over here, these two angles are going to be the same over here. So we have triangle RST. So those two angles match up, and we have to be careful. RS is going to be 2 plus 6 units long. It's going to be 8 units long. And then ST is x plus 2 units long. And once again, the angle they share in common is angle R. So you could see these two triangles have angle-angle similarity. So now what we have to do is we're just going to set up a proportion. So we could say 2 over 4, so that's this bottom side to the right side, has to be equal to the ratio 8 over x plus 2, because once again I'm comparing the bottom to the right, so that ratio has to be the same as the ratio of the bottom side to the right side in the big triangle. And now what we do from here, what we could do is reduce the left side first. So we could just call that 1/2 equals 8 over x plus 2, so that we're working with smaller numbers. And now we cross multiply. 1 times x plus 2 is x plus 2, and then 2 times 8 is 16. And this tells us that x, if we subtract 2 on both sides, is equal to 14. But you have to be careful. This is a very, very, very dangerous trap. They're asking us what is the length of ST, and ST is equal to x plus 2. So we have to plug in x is equal to 14, but plus 2 tells us ST is equal to 16. So choice 4 is our answer.